Hey everyone, this is Tom Kraz. Welcome to my channel. Today we're going to do a CTF challenge from hackmyvm.eu. This one is called Pingme. It's quite a quick one, but it's a reasonably long video for me, so I'm not going to mess about. All links, etc. will be in the description. Let's boot it up and get started. So this virtual machine is Oracle VirtualBox, and you can download it from hackmyvm and you can import it in as an appliance. Once imported, you got to scan your network to see what the IP address of it is. So here we go. We got 192.168.186.19. Quick nmap. I have done this one before, so if I was to do it in real time, this video will be about an hour and a half long. So doing a quick nmap will tell us that there's a HTTP port open, and if we open that HTTP port on inside Firefox, we get a website that just basically pings back the host. So the IP address of the enumeration block art system I'm using is 192.168.186.150. This one is 19. So as you can see, the website is just pinging back my IP address. Very interesting. Let's see. So first step here is probably to run a Wireshark against the traffic and see what's happening. So let's spin up Wireshark, capture some traffic, see what's going on. So this is running as root, which is no good. Control C. So I'm using Screen here. If you've not used Screen before, Screen is a tool to manage your terminal. You can have multiple terminals running within the same screen. It's very useful. So we do sudo wireshark password. I can't run it as root, because if I run it as root, it won't display on the screen. I need to run it as sudo so it knows which screen to display it on. So we can enter an IP filter here. So host 1919. We have to use a display filter inside Wireshark. 2.168.186. What do we say? 19. And let's capture the traffic. Okay. So let's refresh this page, see what Wireshark is telling us. Okay, so Wireshark is saying there are some TCP packets, which I guess are coming from the HTML code. And we've got some ICM packets as well. Now this is an unusual one. As I said, I've done this before, so I already know what's going on here. If you see the packet data itself, you can see the username down here. And if I look at the next request, you can see the username of is pinger. This is a bit messy. You can use some command line functions with tshark to clean it up. Maybe we'll get into that later on. And we can see that there's a password. And then the last echo request, we can see that there's a password capital P exclamation mark ngm3. So let's see if we can SSH to our server using these users. SSH ping pinger at 192.168.186.19, and the password was no. Okay, this is because I've done it before. I need to delete this line in known hosts. So it's line 15. Let's take a look. Go to line 15 VI, delete the line, back out, and okay, host verification key failed. Still the same error. Okay, it's duplicated. Where is it? Line 14? Did I already delete it? To be honest, it doesn't really matter. I'm just going to delete the whole file because I don't really care about this file, because this is my test machine. SSH pinger. Yes, I want to add it, and the password is P exclamation mark and GM3. Yay, I got in. We'll stop Wireshark for the moment. We don't need it anymore. Delete it. Quit without saving. Perfect. Now we're onto our system. Let's have a look. When you're enumerating a server, one of the first things you have to do is look at sudo -l, because I mean it's the most obvious place for these CTFs. Sudo -l, take a look at things like the SUID bits, cron jobs, this kind of stuff. But in this case, it's sudo -l. We can see that it's running this the script that I've not heard of before, so I think it's a custom job for the CTF. Let's have a look at the file type. We can see it's a born again shell. It's an executable, ls-l on it. It's owned by root, but executable by everyone. Let's take a look inside it. And we see echo send file by ping. Only sends one character at a time. No error checking. Just a proof of concept for hackmyvm. Okay, let's take a look. So, okay, so we take an input file. We iterate that input file one character at a time. And using ping, we send a hexadecimal value of the file as packet info for the ping. Okay, this is new. It's not something I've ever done before. Okay, you can use tshark to get the last byte. Okay, let's just try it out here. Okay, I think we need our Wireshark again. That's my bad. And let's see, host. Okay, it's already there. It is host packet snippet. We'll make this a bit smaller. Back to our screen. Okay. Echo G test. We put us into a file because this echoes a file. So let's just create a temp file and have a look at it. Data.out. Okay. Cat temp data out. Okay, so there's our file. Okay, we don't like this because this is capturing SSH traffic. IP.address. Okay, we can copy this one. IP.addr equals 1. So you have with Wireshark, you've got display filters and capture filters. The capture filter is the filter you apply when you're capturing traffic, and the display filter is what you type into this bar here. They're both different, and they have different syntax as well, which makes life a lot more trickier. Learning Wireshark. .19 and ICMP traffic. Okay, let's do the filter here. Okay, let's ping our host. Sometimes when you're doing all this stuff, when you're typing numbers and colons and brackets can be tricky, so I find it easier if I just export a variable to the shell that has the IP address in it. So I tend to call it IP equals 192.168.1.6.19. So this is our host, so we can ping and then use that variable value and ping. And we're getting nothing. 192.168.186.19 and we're pinging ourselves. Ping 192.168.186. I was just pinging myself. God, what a dunderhead. Okay, now here we go. This is much better. So ping. As you can see, usually the packet data in ping is pretty much not much good. Just number 10123445. I'm not an expert in ping. Not sure what that means. I'm sure it has some significance. So let's try using our sudo package. So let's clear the screen. Sudo -l. So it's copied into the buffer, paste it up, and okay, so we need an IP address. So let's try our hostname 168.150, and then the file, it was temp data.out. Okay. It didn't seem to do anything. You know, the worst thing is the typing. 192.168.168, not 18. Yeah. Ooh. You know, I'm such a dunderhead. The IP address is wrong. Let me just make the screen bigger. Make it even bigger, because that's just useless. One thing I'm not liking about this Black Arch Linux is this resizing Windows. It's tiny. I mean, you have to be pinpoint perfect in order to resize them. But yeah, it's probably some setting I can change. Everything is cool in the gang. Okay, 186. dot 150 out. Yay. Okay, so let's just clear up our mess over here. Okay, so we want requests. So we want, actually, to be honest, let's clear up this address. We only want the source address. Let's apply that filter. Okay, let's put it down the bottom here so you can see all the newly captured traffic. And now we have some new traffic. Okay, what have we got? Okay, so TTTTTT, EEEEE, SSSS, TTTT. So that's my word. And it sends a last packet of a full stop. Okay. How is this of use to us? Wow, because this is sudo command, it can read any file. For example, I cannot read etc shadow file, permission denied, but my sudo file can. So I could possibly dump all of this into the sudo version of this file. So if I do it without sudo, I should get an error. SHADO shadow, permission denied. What happens if I dump it into sudo? Okay, so let's get our screen ready and blast it out. Whoa, that's a lot of packets. That is a lot of packets. Okay, okay, where's my original packet? Here we go. What have we got? ROT. And we got the dollar. We've got the exclamation mark. We do. Okay. So this is after cutting out the shadow file. So we could possibly rebuild the shadow file using the output from this. We could definitely use tshark in order to get the output and build up the password. We might give that a go in a minute. But you have to remember this CTF is about flags, and all they're really asking us is to get 2 flags. First, the user flag, which is obviously maybe the Pingme user. Let's take a look. Yeah, it's there. And the next one is the root flag. So we could rebuild a root because we have access to the sudo command. It would be just a simple matter of getting out the root.txt file. And there we go. We could manually rebuild it. Okay, so that's pretty much how you get the flags. For the rest of this video, I'm going to describe how to use tshark to clean it all up and get something useful. So if you just wanted the flags information, you can drop out. If you want to see how tshark works and how we can capture the rest of the flag in a more manageable way, and maybe get the root password in a shadow file hash, or get maybe something more interesting. Okay. Alright, so tshark. Tshark is the command line interface for Wireshark, and we can use it to capture lots of really useful stuff. So let's open up another window here. Okay, so we have screen here. So as I mentioned, screen is brilliant because in the same terminal window, I'm able to open up a new console, and still the other one is running. Many things you can do with screen. You can split it. There's a different command called tmux, I think, which is probably a more modern version. But screen comes with most distributions of Linux, particularly production versions. Red Hat Enterprise Linux comes with it, even the older versions. So if you're working in production environments, screen is probably more useful. tmux is not available everywhere. Okay, so tshark. Once you've installed Wireshark, you should have tshark. So the first thing with tshark is we need to run it as root. So let's just jump up to root here. Make my life easier because typing sudo all the way will make my life crazy. Just like trying to type makes my life crazy. Okay. And first of all, we have to look at the interfaces that tshark can use. So it's tshark -d. And we can see that we've got our main interface. So we can do tshark -i for the interface and the name of the interface, and we can do -f for a capture filter. Remember, there are 2 types of filters. There are display filters, which is -y, and capture filters, -f. And we can do source oops, I could get this wrong. 192.168.186.19. Yeah, that works. Let's give it a test. Okay, we will just ping 192.168. Ooh, what? Does it ping? Okay. Ah, this is SSH, right? Okay, we don't want SSH. So, and not actually, instead of ruling out everything, let's just rule in what we need. And ICMP. Okay. Now, let's go back to our screen. Type 192.166.150. Give it a ping to our host. Is it working? It is working. Very good. One thing I noticed about tshark is if you pipe the output into another command on a live system, I mean on a live scan and not a package file or a pcap file, you have a problem with the pipe because it will never pipe because the command will never stop. So it needs to stop. So basically tshark needs to stop processing and can pipe the output into the next command. So in our case, we're going to use grep, and we're going to need to stop. So we're lucky in that we can set the number of packets to capture. So if I I'm going to only capture, for example, in this case, 4. Whoa, see, sorry, I've got to put in the number. 4 packets. 1, 2, 3, 4, and it stops, which is good because it lines up then with our command. Say, let's go back to our test example. Test. Okay, this lines up perfectly with this because if you see, it actually tells you how many packets. So 5 packets. Let's capture 5 packets and see what we got. Bingo, 5 packets, and it closes. Now, this isn't much good because we only see a very high level packet information. And we want to see more details. Luckily for us, tshark allows you to see the hex code inside, the hexadecimal value inside the packets. So that's the minus x. So let's run it again. Obviously we have to hit the enter button. Let's run it again, and now we can see the hexadecimal values. And now we can see the value of the hex value of the packet. Now, I'm not an expert in any of this packet analysis stuff. I just know Linux extremely well, command line utilities, and how to manipulate data. So one thing I noticed here, and I can't exactly tell you why, is this line 00050 and 00060 seems to be quite standard, and it seems to always gives you the letter. I don't know why it's doing this. Maybe someone out there knows. Please leave some information in the comments. So we can use Linux command line utilities to clean it up and build our command. So let's do a while true, so I don't have to keep typing this thing. While true do, we can copy our command here. Copy and paste, and we can make it sleep for say 3 seconds between each run. Done. Okay. Oh, while true do. Oh yeah, the first semicolon is in the wrong place. Oh Jesus, I made a right mess of that. Okay, first semicolon is in the wrong place. It should be before the do. Now, okay, so it just runs it. Okay, and we can kind of leave this over here in the background, doing its thing. And we can just grep, let's say we can grep, let's say this is just 0060 stuff. Boom. So, TEST. Now, so now we can see our command is kind of gone a bit screwy, but it doesn't matter. We need this column, the last column, and we can use awk to do that. Awk is a command line utility. It's almost like a programming language to manipulate string and data. It has some really good features. In particular, when it comes to printing out columns, it's really good, and it has some variables built in. The nf variable is the number of fields. So for example, if you have something with 3 rows, then nf will have the value of 3, and then if you print the number 3, it will always print the third column, which in this case is the last column. So nf will always print the last column. Okay, let's give it a blast. And now you see we get this TT. Now this isn't much good because we have duplicates, so let's see if we can clean up the duplicates. So there's a cut minus p, is it? Cut minus p1. Let's have a look. Does this work? No. Maybe it's -1. No. Okay, bear with me. I look up the man page for cut in my other window. Yeah, okay. Honestly, I've done this before. I just completely forgotten. And cut. Okay. Character list. Select only one of these characters. Okay, so let's try minus. It's definitely the right one. Minus. Okay, let's try -2. Cut minus. What was it? Cut -2. No, it's not working. Ah, it's cut minus C1. Yeah, sorry, it was cut minus C1. What I was going P. Okay, so we need it all in one line, and that's where xargs comes in nicely. We can run the same command, xargs, we'll do it all in one line. Now there's some spaces, so we can do sed and get rid of the spaces and replace them with nothing. And now we have our line word test, and we can see that each line ends with a full stop, so we can use a full stop as some sort of delimiter maybe. Okay, so what happens then? Let's go back to our thing here. What happens if we bring this back over here and take a look at the etc shadow file? Yeah, okay, we did have a sudo where we ran the etc shadow file. Okay, let's do it this way, right? So we know that the root.txt is 21 packets. So what if we change our commands to capture 21 packets? Does it give it something interesting? If we run it, okay. Look, it gives us our key. Let's see if we can take this to the next level. What happens if we do it with the etc shadow file? Can we get a clean version of the... I know what happens here. I've already done this. Okay, so this is quite a big one. I might add another sed here to... Let's see if I can figure this out. Full stop needs to be escaped because it's a regular expression. And let's see if we can replace it with a new line. Does anything interesting happen here? It was 901 packets. 10, sorry. Let's replace this with 910. What do we get when we send it? We get nothing because I made a mess of something. Let's just clear... Okay, I know exactly what's wrong because sec is not a command. You guys must be having great fun watching me making all these mistakes. Okay. Hey, look, we get a copy of the etc shadow file. That's pretty cool. Okay, there must be some full stop inside the shadow file. Yeah, okay, so there's obviously full stops inside this file. And it's replacing it with carriage returns. Yeah, okay, but look, you get the point. You can also just scrap out this last command. You can also just get rid of this piece here. And you can run the commands. What do we get? We get it all in one line. Wonderful. The etc shadow file is colon delimited, so we could possibly just use a delimiter. We could possibly just do a cut minus d for a delimiter, colon minus f 1 2. Let's have a look at this. So this is the beauty of Linux. You can just build up on commands. You can chain them and make stuff do what you never expected it to do. Here we go. Right, so there is our hashed password for root. It's not hashed, actually. It looks like it's encrypted. Okay. So you could probably use John the Ripper to do that. What else could we look at? Maybe there is there a root? Is there a root.ssh.id underscore RSA file? There is. Surprise, surprise. And you can. Oh wow, this is a big one. Whew. Okay. 2602. I think I'll go back to my full stop one on this because I think it will work here. There should be no full stops inside this file. 2602. And I'm going to just use T, which allows us to see on the screen, pipe to file. Temp, okay, let's see, key dot priv. Boop. And let's send it. My musical entertainment while we do this. Yeah, not very interesting. Okay. Nearly there. Okay. Now, look. We've got a SSH private key. It doesn't look right, though. This weird stuff here at the end with the 2. I don't know where that's coming from. vi temp. What do I call it? Key.priv. Okay, so let's just zap that. I don't know why spaces are here. I don't care. I don't really care, but I'm just going to get rid of them. Okay. Come on, fingers. Don't let me down. Okay, so that's the key. Let's change ownership. So all private keys need to have a very hardened permissions. What was it? Temp key.priv. Okay. SSH minus I temp key.priv. Root as, come on now, I haven't tested this yet, so who knows what's going to 6.19. Yes. Haha! And it worked. ID root temp. Now, I have another post, a written post on this. So I think this is the right way to get access to these servers. I haven't talked to the author, but I'm presuming this is the right way. And there's a wrong way. If you head on over to my blog post, you will see the wrong way, which is a bit more convoluted. And the reason I didn't do this live is because I completely took the wrong approach and went down the HTTP header side and tried to hack the box by spawning a reverse shell on HTTP headers. Anyway, take a look at my page, my blog page. You might find it interesting. And then the dirty pipe exploit that came out a few weeks ago. This system is also vulnerable to it, and it's a very easy exploit. You just copy down the code from GitHub, run it on your system. You've got root access. It's ridiculously easy. But the author, I presume, didn't intend any of that. So this is Tom Krause signing off. Thank you very much for listening to me and watching me my bad typing. I will talk to you guys all later on. Bye bye.